Welcome back, everybody. We are going to start Chapter 7 on polynomials and quadratics. Let's start off with just polynomial basics and how to add and subtract. Go ahead and pause the video to write down the vocabulary. All right, so let's take a look at some examples. Polynomial. Is it a polynomial or not? So we know that polynomials have to be positive whole numbers. If I look at example A, we have negative 2x to the third, 5x to the first, and 8. Each one of those pieces is a term. So this has three terms, one term, two terms, three terms, because there's three pieces or parts that are separated by adding or subtracting. We have an exponent of a third power and a first power. Those are positive whole numbers. And so, yes, this is a polynomial. Standard form means that we would write this in order from greatest exponent to least exponent. So our exponents are third power, first power, and then no variable. 3 comes before 1 in terms of greatest to least. And so this is written in standard form already. Because this is already written in standard form, then we know that our highest exponent is 3, and that makes our degree the third degree. Letter B. Our exponents are 3 and 4. Those are positive whole numbers, and so yes, this is a polynomial. Standard form, fourth power comes before third power, so I have the square root of 2, x to the fourth. This is a negative 0.8, x to the third, and then minus 12 is my constant term. Now we have standard form, and this is a fourth degree because 4 is our highest exponent. Example C, we have x squared and x to the negative first. Well, this right here is not a positive whole number. And so because that is not a positive whole number, this is not a polynomial, and I don't need to worry about standard form, degree, or anything else. Letter D. Our exponents are 2 and x. Well, doesn't say anything about having a variable, but remember, we can put absolutely anything we want into that variable. It could be a 2/3, it could be a negative 9/7, it could be a negative 262. So because of this, that makes this not a polynomial. If it is not a polynomial, we don't worry about standard form, degree, or anything like that. Example E. We have a first power and a third power. Those are positive whole numbers. So yes, this is a polynomial. Standard form, the third power is our highest degree. There is a negative in front of it, so negative x to the third. This is a positive 15, so plus 15x, and then plus 3 because our constant term would be last. Our highest value is a 3, so this is a third degree. Example F, our exponents are squared and first power. Those are positive whole numbers, so this is a polynomial. Standard form, our highest exponent is x squared, so 9x squared minus 2x minus 8. Our largest exponent is 2, so this is a second degree polynomial. classifying. So classifying, now we're talking about, is this a monomial, binomial, trinomial, or just a polynomial? And remember, anything more than 3 terms, we'll just call it a polynomial. If I'm looking at this first example, 3z to the 4th, there's only one term here. So this would be a monomial. Because there's only one thing, this is standard form. I can't rewrite anything because there's only one thing there. Our exponent is 4, so this is a 4th degree. And our leading coefficient is -3. LC is short for leading coefficient. Letter B, I have 1, 2, 3 chunks or 3 terms. So this is a trinomial. X squared is our highest number, so for standard form, I'll put SF for standard form, we have 5x squared minus x to the first. That's a positive 4, so our constant would be +4. This is a 2nd degree, and then our leading coefficient is 5. Letter C. There are 2 terms. 2 terms makes this a binomial. Our highest degree is this 5th power, so standard form would be q to the 5th plus 8q. This is a 5th degree because our highest exponent is 5. And our leading coefficient, remember, if there's nothing else in front of that, then it's a 1. Letter D. We have 1, 2, 3, 4 terms. Because there's 4 terms, it does not have a special name. It's just called a polynomial. Our highest exponent is 5. So our standard form for that would be -6x to the 5th plus 4x to the 3rd plus 2x squared minus 1. Our degree would be 5th because our highest exponent is 5. And our leading coefficient there would be -6. Letter E. I know it's hard to see here. We have 1, 2, 3, 4 terms. So for 4 terms, again, that's a polynomial. It doesn't have any special name really. Standard form, our highest exponent is that x to the 4th, and there's a negative in front. So we have -x to the 4th plus x squared plus x plus 9. That makes that a 4th degree with a leading coefficient of -1, because that, even though it's not there, is a -1. Our last example here, we have x plus 4. That's 2 terms, and so this would be called a binomial. Our highest exponent is 1, so this is already in standard form. The degree then would be a 1st degree, and our leading coefficient would be 1. Pause the video and try the U-tries 1 through 6. Adding and subtracting polynomials. All right, we are combining like terms. Remember, like terms have the same variables to the same exponents. When we find our like terms, the exponents do not change, and we only ever add or subtract the coefficients. Be careful, because they're not always going to be in standard form when we're looking at the problems that we're working with. So sometimes I kind of find my own way to note my like terms by putting similar symbols around them. So I underline my x cubed, and then I circled my x squares. And those are the only like terms that I have. This is a 1 in front of that x cubed, so 2 plus 1 is 3x to the third. Negative 5 plus 2 is negative 3x squared. Now, the x and the minus 1 do not have like terms, so we're just writing that down, plus x minus 1. Now, a reminder that we always write our answer in standard form. So as I look at what I wrote, I have third power, second power, first power, constant. That is in standard form, so that one is ready to go. Letter B. Another way that we can write this is we can put our like terms lined up in columns. So if I take this polynomial or trinomial on the right, because there's 1, 2, 3 terms, and I put like terms, we have an x squared, a 4x, and a 10. And we're adding. There's a 1 here, so 3 plus 1 is 4x squared. There's a 1 here. 1 plus 4 is 5x. Negative 6 plus 10 is positive 4. If I take a look at this, we have squared first and then constant terms, so that is in standard form. And we have no other like terms to combine, so that's our answer. For letter C, with the subtraction, sometimes we forget that we're subtracting absolutely everything in this right set of parentheses. So I like to distribute that subtraction, which is basically multiplying by negative 1 and changing all the signs. That way I don't forget. I have 4n squared plus 2n squared, which is 6n squared. This 2n doesn't have a like term. Remember, we changed it to negative, so I'm going to put minus 2n. And then 5 plus 4 is positive 9. If I look at my answer, second power, first power constant, and so that is in standard form. I'm going to do the same thing for letter D. I'm going to go ahead and distribute that negative 1 to change my signs. Again, we can write these underneath each other for like terms. 4x squared plus negative 3x squared is 1x squared. Negative 3 plus 1 is negative 2x. And 5 plus 8 is positive 13. Second power, first power constant. So this is in standard form. There's no other like terms, so I can't simplify further. Go ahead and try U-Tries 8 through 11. We'll see you tomorrow. Thanks for joining.